Hi everybody, Mrs. Jones here. In this video, we are going to talk about graphing linear inequalities. And the reason I have a person on a ladder there is that my students often hear me say that we're climbing the ladder, right, of algebra. So this is an example of this. You have learned inequalities on the number line. You've learned now how to graph lines on a coordinate plane. And so today we're going to combine both of those things, and you are going to learn how to graph linear inequalities. So just a quick recap. Let's go through all of the graphing things that you have learned so far this year. You've learned a lot. You've learned about slope-intercept form, which hopefully you remember is our y equals mx plus b, right? Where x and y are coordinates on the graph. M is your slope and b is your y-intercept. You also learned about standard form, which is that ax plus by equals c. And remember, that's when we use the cover-up method to graph with our intercepts. You've also learned about point slope form, where x and y, again, are coordinates on the graph, but then x sub 1 and y sub 1 is a point from a specific point from the graph, and m is the slope. You've learned about horizontal lines, right, with slope due. This is zero fun, and it's going to be y equals some specific number. You've also learned about vertical lines, right, and that's with an undefined slope, right? Again, thinking about slope dude, and that's when you write x equals a number. So you've learned a lot. You've also learned probably last year in 7th grade, and we did a little bit of it in the beginning of this year, is all about graphing inequalities. So you learned that when you have a greater than or a less than symbol, you are going to draw an open dot. So in this example here where it says x is greater than 7, I have an open dot on the 7 because I want all numbers that are bigger than 7, but I don't want to include the number 7. You also learned that when you have less than or equal to or greater than or equal to symbols, you do a filled in dot. And so that means when I have x is greater than or equal to 7, I want to fill in the 7 because I want numbers bigger than 7, but I also now want to include the 7. So when we take our graphing lines and we take this idea of solid or filled in dots, it actually comes into how we graph a dashed or solid line. But then there's a piece of this that is shading as well. So I'm going to show you what this all means. So let's first think about this line here. I want you to imagine for a second that this says y equals 1/2 x minus 4. So let's pretend that it's just a regular line. We know that's in slope-intercept form. We know I can really nicely find my y-intercept of -4, and my slope is going to be 1/2, just like this. Okay? Now what we need to do, though, is we're going to, ignore this line, and now let's think about the fact that it's an inequality. I'm going to draw the line to connect my dots. It's going to be about there. And this time, notice how the inequality is a less than symbol. That means that my line is going to be dotted. And so it's going to be dotted because it doesn't include the points on that line. Just like when you had a less than symbol on a number line, you had an open dot. Well, we're not drawing a dot, we're drawing a line. And instead of drawing an open dot, we're now drawing a dotted line, right? We kind of see the opening in our dotted spots. Now, the last step of this is we actually need to do some shading, right? So when we're on the number line, we're drawing an arrow one way or the other. Instead of drawing an arrow, we're going to shade on our graph. And so the way that we have to do this is we have to figure out, am I going to shade above the line or am I going to shade below the line? And the best way to do that is to test a point. What point do you think might be the easiest one to test? Well, how about this one right here? This magical point of 0, 0, right? Our origin. Plugging in 0 is really straightforward. So we're going to plug in 0 into both x and y. And again, plugging in 0 is really straightforward because whenever I multiply by 0, I end up with 0. So if I do 0 is less than, well, 1/2 times 0, again, that's just going to get me to 0, minus 4. 0 is less than -4. Now, if we look at this, is 0 less than -4? Is that a true statement or a false statement? That's a false statement. This does not work. So what that means is that our origin, our 0, 0, does not work in the inequality, which means we don't want to shade where the origin is. We want to shade where the origin is not. So my final answer is going to look like that. Okay, let's move on. and try something similar. What if we had, again, this is the same line, you'll notice, 1 half x minus 4. However, notice that the inequality symbol has switched here. So again, we're going to test this point, and we're going to plug in our 0, 0 into x and y. And I end up with 0 is greater than 0 minus 4, or 0 is greater than negative 4. That is, in fact, a true statement, which means if it's true, I want to include that point with my shading. So this time, I'm going to shade above the line everywhere up here. All right, let's try another one. Y equals 3x minus 5. I know that this is in slope-intercept form, so I know I'm going to graph a y-intercept of negative 5. I know my slope is 3, or remember I can think about it as 3 over 1. So I'm going to go up 3 and over 1, up 3 and over 1. And then I'm going to connect my dots with a line that's going to be about there. This time, notice my line is going to be solid. So do you see here how you have a greater than or equals to? That means that my line this time, I'm going to keep it solid because I want to include the points that are on that line. Now I need to figure out where to shade. So again, that means we're going to test a point. What's the magical point to test? Our origin. So 0 is greater than or equal to 3 times 0 minus 5. That's going to end up with 0 is greater than or equal to 0 minus 5, which is 0 is greater than or equal to negative 5. True or false? That's true, right? That means 0 is bigger than negative 5, which means the origin works. So when I shade, I'm going to include the origin. So I'm going to shade everything on this side of the line. All right, let's try another. This is in standard form. Hopefully you remember that when we graph standard form, remember we are going to cover up. So let's first cover up our 3x. So I'm going to get 4y equals 12. And so that's going to tell me that my y-intercept is going to be positive 3. If I now want to cover up my y in order to get my x-intercept, 3x equals 12, which means my x-intercept will be 4. Now that I have my two intercepts, I can draw a line to connect them. Notice this time that, again, we have just a greater than symbol, which means my line is going to be dotted, okay? A dotted line. Now, last but not least, we need to test a point. What's the magical point to test? That origin. So I'm going to plug in 0, 0. So 3 times 0 plus 4 times 0 is bigger than 12. So 0, 3 times 0 is 0, plus 4 times 0 is 0, is greater than 12. Is 0 bigger than 12? Is that true or false? That's false. This does not work, which means I'm going to shade on the opposite side. The origin does not work, so I don't want to include it. So that means I'm going to shade everywhere up here. And I know I'm covering up my work, but I think you get the idea. Okay. How about point slope form? You should remember how to graph point slope form, right? Remember, we have y minus y1 equals m times x minus x1. So let's first think about my slope. We can see is going to be 1/2. And then we want to think about the point. The point here is going to be 2 comma negative 3. So when I graph 2 comma negative 3, I'm going to end up at about here. I'm then going to graph my slope of 1/2. So I'm going to go up 1 over 2. And then I'm going to connect the dots with a line. My line is going to remain solid because it's a less than or equal to symbol, sorry. And now I need to test a point. Remember, we want to test that origin. So I'm going to plug in 0, 0. 0 plus 3 is less than or equal to 1/2 of 0 minus 2. So I end up with 3 on the left side is less than or equal to 1/2. 0 minus 2 is negative 2. 3 is less than or equal to 1/2 times negative 2. Sorry, here is going to get me to negative 1. So is 3 smaller than or equal to negative 1? That's false, right? That does not work, which means I don't want to include the origin. I'm going to include where the origin is not. And what you could do if you wanted to is to double check. let's take a point over here that we know works. So let's take this point right here that's in my shading. So that's going to be 4, comma, -4. We could plug this in to double check. So if I plug in -4 plus 3 is less than or equal to 1/2 of 4 minus 2. Well, -4 plus 3 is going to be -1, is less than or equal to 1/2 of 4 minus 2 is 2. Is -1 less than or equal to +1? Yes, so I've shaded correctly. Okay, I'm going to pause. I want you to pause the video here, and I want you to try to graph this one on your own. Remember, this is going to be the cover-up method because it's in standard form. Okay, you're back. Hopefully, you discovered your x-intercept is going to be -6, 0. Your y-intercept is going to be 0, -2. Hopefully, you tested the origin and you realized that, yes, the origin works, and you had a dotted line, so your graph should look something like what's on the screen. Okay, one more. I want you to pause the video and try this one on your own. All right, this was in slope-intercept form, so hopefully you had a slope of -4. You did a y-intercept of -4, a slope of 2/3, so up 2 over 3. Hopefully you left it as a solid line because it's less than or equal to. And then hopefully you plugged in the origin and figured out it does not work, right? 0 is not less than or equal to -4, so you should have shaded on the opposite side where the origin is not included. All right, so just to recap, the keys to success for graphing inequalities. Step 1 is we're going to plot those points. Step 2 is we're going to figure out is it dashed or solid line based on the inequality. Step 3 is we're going to test a point. What's our favorite point to test? Obviously the origin, 0, 0. And then step 4, you're going to shade. If the origin works, you shade where the origin is. If the origin doesn't work, you're going to shade on the other side. Hopefully this helps. If you have any questions, bring them to class, and good luck with your work.